Let's discuss a question from heat transfer. So it is asked that under what condition the film efficiency can be 100%. So what is film efficiency? Let's have a fin kind of a fin. So in normal case, let's say if the base temperature is 100, normal case, as you look at the profile, the temperatures at various points keeps on decreasing. Let's say this is the profile and there is an actual, in normal case this is what happened. There is a thermal gradient that sets up across the length of the fin and there is some heat transfer, actual heat transfer. Now ideally what I would want is the entire, let's say the base temperature 100, the entire, if the thermal conductivity is very high, such that the entire temperature of the fin is at the base temperature, then it's ideal heat transfer to the atmosphere. Okay, the heat transfer will be more actually in the second case. So Q ideal will be more than Q actual, and this ratio is what is defined as efficiency of the fin. That is Q actual when there is a thermal gradient set up because of the conductivity by Q ideal, which is when the entire temperature is at constant. So the efficiency obviously will be 100% when your Q ideal is equal to Q actual. For this to happen, the temperature of the entire film should be same. So that is point number one. The temperature, entire film should be at a constant temperature. Second thing is, if there is a very high thermal conductivity, almost infinite, close to infinite, then the temperature difference, the thermal gradient will be very less, because Q, if you go by the Fourier heat transfer, Ka dt by dx. Okay, so if my thermal conductivity is almost very high, almost close to infinity, my temperature gradient will be 0 for some reasonable heat transfer that is taking place across the film, right? So dt will be 0, spatial gradient will be almost 0. That means that it's almost at a constant temperature. So both A and B satisfies a case when ideal heat transfer to the atmosphere becomes equal to the actual heat transfer, that is when efficiency is 100%. Thank you.